Okay, hopefully. Getting back in. Oh, and because of that, the camera has bricked. Try to unplug, replug the camera. Does not appear to have fixed it. So, I guess we'll turn the camera off and move on from there. So yeah, my son has unplugged the power. I've got most things plugged into the UPS, but where he unplugged it, it got the internet router and apparently my my camera. So the camera did not come up happy, but the internet's back up. So we're gonna press on instead of fixing the camera, which will probably require me to shut down OBS. We're just gonna do this. So here we are. Let's see. Basically, this thing roughly like that. Back into my scratch buffer. Steal the switch statement. We gotta write this out for each coding. Again, there's a lot of similarity and override lap, but we're just gonna simplify a bit. It's gonna be one of the fun pieces here. Because each of these is a string within a string. There. Something like that. So we're gonna find quote. Should be something like that. Okay. Right line. Let's see here. Quote 1, 2, 3, 4. Reindent everything again. Oops. There we go. Latin1 needs invalid byte, otherwise that is the end of those complaints. ASCII doesn't need invalid byte. Oh, no. Latin doesn't have an invalid byte. Okay. All right. so there we go. Sorry about the interruption in the stream. It's not the ideal, that's for sure. Whoa. Better. Where's this one going? Okay, we're almost there. What else do we need to do? It's clear, update, and advance. Now. Oh. This one as well. So if we're in UTF8, the value. Our value type is different for the other two. So we can go with just a char. Okay. All right. Advance, clear, and update. Clear is probably the easiest one. Advance actually shouldn't be that hard either. It's basically right line 1, 2, 3, 4. Else, everything else to this. Also very similar. So UTF8 character reference. Let's look at the advance. Okay. Interesting. This is basically what we have to do for UTF8. So except this one I don't like. Okay. So we advance. Quote. Indent. New line quote. 1, 2, 3, 4. There we go. That's basically the hard case. Down to here. Oops. Ugh, what happened? I had to refresh the stream. Yeah, kids. My son, he's 3, 4. Yeah, he pulled the power cord on our internet. So that's always the way it goes, I'm afraid. Get on a roll and then everything dies. Okay, case UTF8. Break. KTV project. Encoding. Latin1. Break. Case ASCII. End of that. Okay. My camera's off, yeah. So when he pulled the plug on the internet, it bounced my camera as well. And then when I started back up, it was frozen. So if I just turned the camera off. It's I mean, we can turn it back on, but it's not doing anything anymore. So let's see here, video capture. It's frozen. I'm frozen, looking very thoughtful. Basically, that was when he pulled the plug. And OBS is stuck. So I can shut down the stream again, restart OBS, and get my camera back, but that's not the worst face I could have been stuck with. So you ever notice that? Like if you have a camera and it's capturing your face, then your face looks weird when it gets caught in different situations. Do ASCII first. Invalid byte. Plus char offset. And update. We're in uninitialized or end of buffer. There's nothing really to do. There's really not anything to do for the invalid reason. Nothing. ASCII doesn't really recover well from error. So let's just simplify this a bit. Incomplete character means we're at the end of the buffer and we didn't complete the last character. So that's fine. Okay. So there's ASCII. Part of the way. There's the rest of ASCII. So Latin is just like ASCII, but even simpler. There's so many fewer errors to deal with. Actually, advance. If it's valid, and there's literally nothing to do if the stream is not valid. We're at the end of the buffer. Yeah. If it's valid, we move forward. Oh, not byte size. Char offset plus equals. What is just plus plus? Yeah, that's it. There's no byte size. Okay. Let's advance. Clear and update. You'll be amused to look. You just have to reset the source. Okay. So let's see here. If I go to video capture device, pop it up. If I deactivate, activate. Oh, it's back. Aha. No more bemused look for you, JTL. All right. That's good. That's probably better. See, I don't really think of myself as a streamer. I don't really want to learn every last little detail of my system in that regard. It's like, you know what, let's get the camera going. Let's get some audio going. Let's just write some code. Okay. This is not going to be complete. It's not going to work well, and we're going to have lots of issues. But what we're going to do is we're just going to run it. And we're going to see where we compile errors. We're going to see what we've got. This initializer for, yeah, blah, blah, blah. Okay, well, I guess we'll default break there. We shouldn't get here if we don't have a valid encoding. Probably complain about that elsewhere as well. Oh, we don't have enough colons, obviously. I mean, most people only need one, but, you know, this is C. Semicolon, semicolon. Warning. Yep, just like I said, we did not handle the error case here. Put that in our scratch buffer. We're going to run into this again. Okay. Let's switch as well. I've just run into every problem you can think of, like every aspect of every single program that exists. You know, that's how we learn. We just step on rakes over and over again. I've only been streaming for not even 3 months, like 2.5 months, so I've not run into all the errors yet. Someday I will be as wise as you, Pat. I'll have all that experience, but not yet. This statement may fall through. Writer, right line, bunches of strings. I'm assuming it's caused by an above error. So file debug. Try this again. Okay, that was it. We fixed them all. Guess we fixed them all. We compile test. Okay. Yes. So there's our standard int and CAssert that we talked about before. TxtBuffer was written out, so that's fine. What do we call this TxtBuffer? We have a copy paste error there. We have a list of invalid reasons. I think that looks better, so we'll come back and change that. One-liners. We'll probably make this one like that. It's just more consistent. We forgot to close the else. Okay, so let's go change those while we're looking at it. The project writing. All right. This is a, oops. ChrRef. I decided I want this on its own line. I decided I want this on its own line. Formatting. Clear this if, yeah, we did forget the else. Look at that. Close the else. Okay, where else were we? We said the destructor we're going to put on separate lines. There we go. Okay, so we're through the destructor. What else looks okay? Value. Extra white space there. Equals, not equals. Let's go fix not equals. Space there. And after the other not equals. Yeah, okay. Character offset is valid, invalid reason. Invalid reasons. Oh no, 2C string. Here's our buffer. Where are we at? Oh, yep, that's fine. Character reference, invalid reason names. Seems legit. Okay, well, we can't call this char, that's for sure. I'm gonna call it value. And this is not going to get return. Advance. If it's valid, move forward and update. Update is not rocket science. I think in the case of ASCII, invalid reason. Advance to the next character and update. That looks good. Brings us to after advance. Value character offset. Buffer is valid, invalid reason. Valid reason names. That's the name of the class. One extra blank line, just for good luck. Okay. Let's run this again. And it's still going to be sad, and that's okay. In class initialization of static member. Oh. Can't do that here? That makes me sad. Static const char star. Barely use OBS 2, which is the sad part. I've just hit so many issues. That's why I don't update. I'm still running on an OBS from like 3 years ago. In class initialization of static data member of incomplete. No, clear was not declared. We'll come back to that. Yes. is not a copy constructor. How did we get this here? Interesting. So we're generating output. So we have a tokenizer definition somewhere that tells us these are the rules for how to parse. And we're outputting a single compilation unit that will do all of that. Right now we're at the stage of writing our file handling and our character text handling for different encodings simultaneously. So we're looking at generating that code, which is for now is here, and it outputs this code, which we have to make sure is correct before we can move on. So we're doing character reference. We're not copying strings. Like one of the big design decisions I made was we read a file, or you when you use the parser, you hand it text, right? Whether you load it from a file or whatever. And this text buffer holds it, and it's constant, and it's static, and it doesn't change ever. Everything else points to this text buffer. There's no string copying at all. It's just here's where it is in the buffer, and here's how many bytes it is. But we have to handle 3 encodings: ASCII, Latin1, and UTF8. So this I think these are backwards. So let's go look up here where we go to ChrRef const. We get the other thing. We just do the assignment. We get a buffer. And if the buffer is null, we just clear. Otherwise, we set the buffer. That seems a little bit short. So we hand jammed a class for reuse while we snub things out. And that is this one. So if we get a buffer, we still need to do the update. We still need to do this. Yes, okay. So VB project writing. We're going to put those braces back in. Either way we need them. Let's save the buffer. We have to do these things as well. And offset sometimes. Okay, so that closes that one. That one. Write the line. Write the line. If our encoding is encoding UTF8. UTF8, we need a byte offset. If not, we just need a character offset. And the rest of that as follows. Okay, we're getting there. Slowly, slowly. Char offset. I still have some badly written code here, but we get the buffer, we get our character offset, and we update. With the one with other. That. I think that's more correct, actually. And meld these here. There we go. Okay. Writing code that writes code. It gets a little bit brain twisty. After a while, you start losing track. So if I'm like being really explicit about this is what we're doing, here's what we're doing. Okay, so it doesn't like that still. Fine. We know we didn't find clear. We didn't find update yet. That's fine. Oh, we have UTF8 character refs in there. UTF8 char. Yep, we sure did. Those need to go away. We're going to rename them all like that. Okay, still select those. Clear, clear, update, update. Perfect. So I think if we go to VB test parser, we go down to our character class here. We say straight up, we only support ASCII in this output. ASCII can have an invalid byte error, otherwise these are standard bookkeeping. When we initialize, we clear it. If you hand us a buffer, we actually set ourselves up. Checking like alignment, white space issues. A copy constructor is the same as an assignment in this case. We just do an assignment, let that handle it. Here's the assignment. Test for equality. It's various things. Since we're in ASCII, we can just compare against a character itself. Buffer. I'm not actually sure we need all of these at all. I don't remember needing those. Let's see here. Operator. May not need any comparison. Oh no, we do need comparison. Yes, we do. Leave those there. Okay. These all line up correctly. White space looks good. Looks good. Value, etc., etc. Advance. Lines up okay. Private. Private members. It does not like me initializing this here. Which I guess is fine. We can do it like this. Do this. This. Now all of this is going to come after the class definition. This 1, 2, 3, 4, 1, 2, 3, 4, 4. I'm going to need the modulus S here. This is just ChrRef. But we still must declare it in our class. So before the class ends, static const char star invalid reason names. So we'll declare it inside the class. We will and do that to give them to declare the to define them. So declare and definition are in two different places now, but they are right next to each other, so maybe that's not too bad. Oh, we've got the bots again. Bots are bad on Fridays, I guess. Clear, clear, update, update, update. Perfect. Phew, okay. Brings us to clear and update. Clear isn't too bad. That's going to be an easy one. Update. The UTF8 one will be the worst, and then we'll add in ASCII and Latin1. But this is coming together nicely. I think we'll be done pretty quickly here. But it's almost 2. Probably time for a quick restroom break. So I'll be right back. Okay, and we're back. So, where are we at? We are at clear and update. So, clear, I've had two thoughts. One is when we destruct character reference, we can clear it. That way, nobody gets dangling data if they have a pointer to one. So, I never plan on using any character references which have a pointer. So, we just add a note here. To do if we ever actually use pointers to ChrRef, consider another line. Consider clear. So any dangling pointers will have no false data, something like that. Basically, so you can detect if you have an invalid character, so it's probably deleted somewhere. Maybe dangling pointers. Yeah, whatever. That's one. I've thought it through again, and I don't actually think we need these equals operators. So we're going to do the following. We're going to remove all of these equivalence checks. Write ourselves a note. I don't think we do. Oh wait, no, we do. We do. What am I thinking? That's fine. We do those. Okay, so we're down to clear. And as far as clear goes on a character, it's not actually that bad. So let's just do this in 2 chunks. I think will be like this. Writer, right line. Yep. Anything else? Which does the same thing, but it'll be slightly different. Look to UTF8 character reference for an example. Clear. Actually, almost all of this is same except for this. Everything else is the same. Basically the same, except to search for more of that again. There's only one. Let's go. Yeah. So that will probably work for clear. So if we run our test case again. Oops. Screwed that up. There we go. Have an else problem. There. Just update missing now. So go to VB test parser, reload, come down here to clear. That looks acceptable to me. I want to remove that. Okay, so that's that. Update. Update is absolutely necessary for UTF8, but I don't think it's necessary for the other two. So let's go through the UTF8 case. We're just going to treat it completely separate from the others for now. Because if I'm not wrong, update for UTF8 and ASCII basically boils down to taking the character at the current pointer. So I think we don't care. So let's go to UTF8 character reference. We're going to steal our update function. And yeah, it's a big one. This is why we don't like using UTF8. So what we're going to do is we can go 20, probably coded here. Now we have to write our string or our handling here in such a way what if we do this? 2, 3, 4, 5, and then here, just do that. Yes, we are using go-tos in this program. Isn't that fun? It's going to get way worse. We're going to use so many go-tos, it'll make your head spin. Actually, it's easy to understand. That's one of the reasons this is such a good use case for them. It actually makes it clear what's going on. There we go. Cancel the cleaner, return. Oops, oh, no, that's fine. There, that's basically the whole thing for UTF8. Stolen. So, for those who are interested, UTF8 has a multi byte variable size character encoding. What it is if your first byte, so we're looking at a character, we're in a byte somewhere, and we say if the first bit is 0, then it's a 1-byte character, and it has to be, it's the same as ASCII. So in this case, our byte size is 1. If we get our first 3 bits, so 1, 1, 1, we're going to check the first 3 bits. If they are 1, 1, 0, then it's a 2-byte character. Check the top 4 bits, and we get 1, 1, 1, 0. It's a 3-byte character. And lastly, if we check the top 5 bits, and we get 4 1s and a 0, it's a 4-byte character. Otherwise, it's invalid. Then we say, are we at the end of the, is this a multi-byte character, and are we past the end of the buffer? If it is, then we have an incomplete character at the end of our buffer. So we needed a 4-byte character, and we only had 3 bytes before we hit the end of the text. So that's no good. Then you say, if my size is 1, or my value is just the first byte, and we're done. If we have 2 bytes, then we have to check the second byte for the continuation bits. Continuation bits are the first 2 bits of a byte, and they have to be 1, 0. That's why those weren't an option up here. You have to distinguish between a continuation byte and an initial byte. So if we don't get this continuation 2 bits in the next byte, that's not right. We do not have a valid continuation byte, we are done. Otherwise, we take the first byte and combine it with the second byte, and it's a 2-byte value. Same thing with 3 bits, except we have to check 2 characters for their leading bits. 2 characters. Both have to have the mask. Same thing for 3-byte characters. 4-byte characters. All 3 bytes after the first one have to have the continuation bits. Otherwise, we're done. And if we have an invalid number of bytes, we've already marked that, so it shouldn't get here. Then if we did anything wrong, so as long as we did everything right, we return normally. Otherwise, here's how we set everything to wrong. I think that's it. So as far as this goes, this is UTF-8 in a nutshell. There are more things about UTF-8. For example, there are ranges that you're not allowed to use. And I'm ignoring that. I mean, I'm trying to think if UTF-8 invalid ranges. I don't even know if there's like a succinct list. People talk about the byte sequences and the bit stuff. But I don't know. Don't know that there's any range, like succinct list of UTF, unless I go to the actual, well, I guess it's Unicode standard, isn't it? So I could get the Unicode code point. Okay, so I guess backing up. Unicode is a 32-bit encoding for characters. Every character takes 32 bits. But most characters we deal with are ASCII, so why are we storing 4 bits that are almost going to be all zeros? That's why we take the Unicode code point, so the number it defines, and we use these bits to shrink it down most of the time. Like Chinese characters are up here in 4-byte land. Russian characters, Greek letters, mathematical symbols are in this region. Katakana, hiragana, 3-byte, I don't remember. Anyway, so the more commonly used characters, the ASCII characters, even in foreign languages, this is the most common character set. Probably, most of the time, are going to be in the 1 and 2-byte character range. Kanji obviously won't fit in anything smaller than 3 or 4 bits, so, bytes. Unicode standard. Trying to think if there are. I don't really want to have to read the whole Unicode standard documentation. I guess I could. But I really don't want to slow down my code any more than I already have. Like this checking for valid characters is a pretty heavy lift, and you'll see that when we time the different options. The UTF8 takes time. So if I added a step after all of this here and said, is this within a valid range? It would be is the value between this and this? Is it between this and this? Is it between this and this? Is it between this and this? And there would just be a bunch more of these for every single character I advance over, right? So we're going to skip that. We're not going to check for valid ranges. We'll check for valid bit patterns. That's where we're going to draw the line at. So I'm thinking update. So let's go to let's generate our test file again. It should be fine. It'll complain about update, but we are going to do away with it for ASCII update. So when we construct one, we get an update there, update there in advance, and sometimes in this advance. Okay. So the only reason we have updates broken out for UTF8 is because it is complicated. And there's a lot of ways you can get errors. But in Latin1, there isn't. I guess in ASCII we kind of do. We have to check one thing in ASCII. We're doing the 7-bit ASCII. So let's go to I want to do it. Update. Ooh. I guess we use update. That's fine. We can do this for all 3 versions. Good. So I guess we could instead switch on a coding case thing. And I'm writing a line, which is a variable line. Go break. Okay, CV project coding Latin1 break case project coding ASCII. So Latin1 is the easiest. Let's say we're not valid, invalid reason, none. Actually, char b char offset. We don't have to do any of that. Anyways, if it's valid, that's where we get our value. In Latin1, there's no checking. It just is okay. As long as we aren't past the end. So there we are. This is the one we want. I'm going to say it's valid, it's true. We have no reason to be invalid if our character offset is greater than or equal to our buffer size, are invalid for the reason of being at the end of the buffer. And I guess we can go to invalid character. That's fine. Otherwise, we don't have to. We don't have to anymore. This is simple enough that we can simplify, simplify, simplify. Otherwise, oh, no. Let's put the base back in. If underscore is valid, false. False. And value equals our buffer contents at underscore char offset. That's basically Latin1. The only thing we check for is, are we off the edge of the buffer? Otherwise, we just take the character. So that's pretty straightforward. ASCII, slightly more complicated. Not much. We did that properly. Okay, we have to ask ourselves else. If this character we're trying to look at has the highest bit set. So if it's a negative number, those are two ways of saying the same thing. If we have to have that first bit be 0. If this is not equal to 0, we are invalid. Where's that? Basically just needs this, except instead of end of buffer, we get invalid byte. I think we need to do anything else there. Okay. Is that all the update functions? I think so. I think that's about it. Extra blank line after this one. Alright, let's see how that works. If clause does not guard. Okay. Enumeration error is not handled. Okay. Now it's handled. Look at that. Perfect. Okay. And UTF8 character is not a thing anymore. It may be UTF8, but we do not have to say the name. Okay. It mostly worked. Multiple definitions of invalid reason names. Bring it to the linker stage. I have to practice once while we hack away. Okay, let's do this. While we're testing this, we're just going to build it all together. You know what? These are included by header anyways. Compilation looks good. Okay, VB test parser. Update 1, 2, 3. There it is. Are we valid? Sure. We have no reason to be invalid until we check end of buffer and whether we have an invalid byte. Otherwise, we just take the character. So this is for ASCII. So here's a question. Well, we'll get around to that. Go to the test. We want a VB test parser character reference, which takes the address of a buffer. Or, as long as C dot is valid, C dot advance. index and c dot value, I think is what we called it. If c dot invalid reason is not equal to test parse char reference invalid reason end of buffer. This is a little bit verbose if we're not in a like namespace or anything, but it's okay. This is not how people are supposed to use this. This is how we are using this during development. Then log error scanning text, which is this thing. Oh no, c dot. Let's see what's it called. Invalid reason string. Oh. There. Else log. Text scan. Okay, now we run the test. C was not declared. Oh. We can do that. Okay, now we can run our test example. Invalid byte after H. Okay, so that's obviously a bug. So now got past capital H. We could change it. PV project. This is less than 0. It is not valid ASCII. Check it that way. That's fine too. All right, there we go. Hello world! Exclamation mark. The text buffer said it had 12 bytes, and we have 0 through 11, which is 12. And it completed successfully. So, what if we insert a non-ASCII character? Go to our test. Don't need that anymore. So this will be 13 bytes long. \x. I want. What we could do, let's see here, alt 164. Let's see here. Maybe get an invalid character. Nose real quick. Alt 64. 146. 167. What was it? Okay, 164 is fine. Take that, and then we'll put it in here. 13, 14, 15. So in theory, this is ASCII value 164. And yay. It should hate that letter. I'm going to put it in here. Still a single byte. Invalid byte. At line, at character 6. So 0, 1, 2, 3, 4, 5, 6. Boom. Yeah. Seems to have worked. Good. And honestly, probably the cleaner way would be while is valid. Do the thing and then advance. It's probably a better pattern. It will print the 6th index out now in theory. Yep. It advances. Should ask if it's valid. If it's not valid, if it is valid, it should do this. So why is it doing this? Maybe we could do a test. I have some dangling stuff in an old build. Oh, it's a space. Printed out the space, so this is fine. Just to make it a little more compact. Put it into basically a one-liner. Should be the same thing. Oops. Bit clean. Oh well. Okay. Okay, same thing. So we got the space. We wanted it to be more clear. We could put quotes around the characters. That way we would see the space. So we're going to do a lot more testing around this area of code. So might as well. There we go. There's the space. And character 7 is the invalid byte. Okay, so we have that one. We could also get a get a Russian character or something off the inner googles, or maybe we could do a Greek letter. Something. Just have to find one that's good enough. There's Russian. I think the Greek is above that. Let me do Greek letter. Money symbols. What have we got here? Is that like Hebrew? There we go. There we go. Do something like this. That's a distinctive letter, right? E. There we go. We can do while C invalid reason not equal to not at the end of the buffer. Actually, let's save what I've got here. Oh, we're not at the end of the buffer. Keep advancing. Yeah, C dot is valid. Then we log. Let me try that. So I should skip the 2 bytes. Should skip the 2 bytes for omega and the 1 byte for the NA. And work. Although we can see 6 and 7 disappeared because those are the 2 bytes for omega. 8, 9, 10, and 11 disappeared. I guess that's not a 1 byte character, so maybe I need to force it. Let's see here. What is 164? Let's see here. Let's get an ASCII character that we like. Like, where is the... These are not the ones I'm most familiar with. 160. Anyways, it shouldn't matter. If I go to 164 in octal. Brother, okay, calculator. 164 programmer 164 octal 244. We're gonna cheat. We're gonna stuff in a weird one. Backslash 244. I don't want a single byte failure here. So we could also do things this way. Or we can fail on the first failed byte. We have choices on how we choose to iterate. Okay, so that actually looks pretty reasonable as far as ASCII goes. So the next step, oops, is we're going to regenerate everything with a different encoding. Oops, that's not right. That's not compile test. So this is going to output VB test parser. If we go down to char reference, this is going to support something not ASCII. I said maybe I said Latin1, thank you. Oh, Latin1 is the one that we didn't do. Okay. Fine. Okay. There we go. VV test parser. ChrRef. Now it supports Latin 1. And you'll note that we don't have the invalid byte option anymore. It's gone. Clear update. Update is very simple. End of buffer is really the only way we can be invalid. Let's just get the value. So if we go back to our shell, if we run it, we accept these bytes. Basically, anything that is a byte, Latin 1 will accept. So this is correct. And that is 244, octal for 164. So that is correct. So completed. And since it does less error checking, it's actually going to be much, much, much faster. Okay, so that's good. Lastly, test.vv project, going for UTF8. This one will actually print the characters correctly. This is why we test. Okay. These have got some errors. Reread from disk. Yes, please. Okay. So we have an error there in 2C string. What else do we got? Huh. Somehow didn't get that first line. Okay, so let's do this one at a time. 2C string. Okay, let's bring in null characters. We gotta escape those. I should fix some of it. Next error was this one. Ugh. All right, let's just see how that goes. Much closer. So this does not have value. C string. We're gonna do this. Because we need to clean up this string after we're done. So char star. Temp. There we go. Invalid first byte. So this is what I was talking about. With UTF8, if it's a 1-byte character, it can't be 1-0. So if we go in here and we change it to be this one, oops, daisy. This, and we'll skip over the weird, the invalid 164 value. It worked. So 8, 9, 10. Yep, skipped it. With an error, so we could get other reasons if we wanted to. But if we go with this one, and we get all the letters. So there we go. We can now scan text, ASCII, Latin1, and UTF8, depending on how you configure your project. We will probably stay in UTF8 for a while because it is the most complicated version, and we want to make sure that that gets well exercised. The other ones should be much simpler, so the fact that we can generate Latin1 and ASCII is great, but they don't need nearly as much testing, so we are good to go. So if we go to our journal, notes, character reference can now be generated based on the project encoding specified or configured. Tested in test.cpp. Well, it's going to be explicit ASCII, Latin1, UTF8. That's in this thing. Had to hack up the file to make it work. Remember to unhack the make file someday. We will have to, but we don't have to yet. With that file git status, add everything. ChrRef generated in specified encoding. This may I kind of want to change a couple things real quick. PV project. No, I'll come back to them if we need to later. Okay. So that is that one. There's character reference. Now again, this is a subset of what we're using for our regular expression parsing code. This does not have to be as powerful as that. So that's good. Now, a string reference is going to be very, very similar to the character reference, but not quite. So let's go take a look at. I have a UTF8 string. I do not. So let's go take a look at an example one from my old sandbox. Header core, the end, header core BNB. VB something bars, VB UTF, UTF8 string reference. I actually like that iterator. Although we may implement an iterator version of these things later. We are not yet. Let's just get something up and running somewhat quickly. So a string reference can be empty, or it can reference two characters, inclusive or exclusive of the last character. We can also set a string reference equal to a buffer, and if we leave these defaults as constants, as the default values, it just grabs the whole buffer as a string reference. Again, we're not copying any of the text in our buffer, in our text buffers. We can copy them all. Okay, destructor. We're ignoring the iterators for now. We do need to check equivalence and do assignment, but I don't think any of these other ones matter. Only these ones. Byte count, character count, toString. I did provide myself a convenient hash function. I don't know if I want that right now. We have friend string pairs, which is basically how we implemented these. So I can compare a string reference and a string reference, C string to our reference, and our reference to a C string. Just so I can have easy ways of doing comparisons. Okay. And then again, there are more convenience comparisons here, but I don't think I need them. In fact, I kind of want to do a thing. Let me do a thing. Go to VB project. ChrRef. I'm going to take ChrRef. So it's the same length as StrRef, StrRef. There we go. Okay, so one thing I may want to do is form declare all the classes at the top of the CPP file. Because I might want to use a character to iterate over a string ref or a file buffer. That's an interesting idea. Yeah, we may want to do things a little differently from what we had before. Well, let's go ahead and do a little forward decoration here. Forward declaration class text buffer. ChrRef and StrRef. It will all be wherever each other, just because maybe not needed. Thinking about it. Okay. In the meantime, why don't we go start building up our string reference class? That's basically it stubbed out. What else do we need? So we had an empty constructor. Not have it clear. Clear might be convenient since that's the empty constructor. The destructor, although again, it's literally just a pointer to something and some indices and counts. That's it. So we're gonna simplify this as much as we can from what we've got here from my old sandbox. I didn't know what I needed, so I kind of just threw it all in there. Iterator. I've done a test where I used the iterator versus just managing my own iterator with the characters like we have, and it's faster. But I do want to implement everything in multiple ways so we can compare the performance in a full system, not just like running an iterator against a for loop to see which is faster. It might just be negligible, like right. So over the full run of a full parse of a million lines of code, maybe the overhead, which I can measure if I can contrive where this is the only difference, right? Maybe this in a full system only contributes to a millisecond of difference. In which case, who cares? But if it's like a 5 or 10% difference, like okay, well that's meaningful. So the question is using iterators a meaningful overhead or not? So that's one reason we might put iterators in our text buffer as well as our stream reference. But we're not going to do that for starters. We'll come back around to that. So let's add that to our to-do list so I don't forget. That is one of the many, we're going to write this code 2 different ways kinds of things. Performance measurements. We're going to do implement iterators in StrRef and TxtBuf. Right, so we're going to implement everything 2, 3, 4 different ways, depending on how many ways I can think of to do it. Just so I can compare and measure. Let's see here. So where are we? We're going to skip the iterator for now. I don't feel like doing it. We're going to initialize all of these ways. We're going to get assignment and equivalency checking. Provide a hash. Do I care about a hash right now? This one only matters for UTF8. Really, we're going to simplify this a bunch. I think that's most of the class that we need. String, other. Okay. Let's begin. These are all methods. So let's write us a little macro to deal with that. First of all, remove UTF8 everywhere here. Then we're going to change all ChrRef to ChrRef, which is simple enough. Okay. Now, the nice thing here is that there's really not that much difference between the different encodings when we come to string reference. As long as the characters defining it are valid, we're good. So our only real difference is, do we generate that and this? Okay, so we're going to come in here, 1, 2, 3, 4, do a thing, closing brace, new line, center, and there we go. This should all just pop into being easy peasy, just like that. Okay, with these ones being the only interesting ones. That's basically it stubbed out. The biggest difference is here. PV project. Let's see here. Define underscore encoding. PV project encoding. Oops. On UTF8. Writer. Right line. Otherwise, we just go back on with what we were doing. Then, here, I'm going to go ahead and do this. I'm going to rearrange a little bit. There. That's basically it. I just want to see what the text output looks like. There's no way it's going to work at all. Yeah, lots of issues. Buffer does not name a thing. You know what? That is fair. Oh, right. Okay, we want a semicolon. I guess they can have a semicolon if they want. What else we got? No return statements, obviously. Makes sense. I could test.cpp. Do I want to change the name of the text buffer to TxtBuffer? Or TxtBuf? I don't know. I'm not opposed to it. Nobody's going to see it, so let's be efficient as we want. Project writing. Oops, not that one. I don't like this. We're going to make it consistent with the other one. Consider all right, we'll make that consistent. We'll actually use pointers to consider called clear, so we name data. Okay. Okay, so C string is pretty much stubbed out. This one I'm going to bet falls here. Okay, string reference. This is basically the clear function, or will be. Let's see. There's another copy of what would be clear. Okay. How we doing? Got us. Okay. Maybe project rating. The destructor will also call clear, or at least considered clear. We don't have to right now. This one is going to be the contents of this equals other. So you have the copy operator. Which looks like this, except not quite. There are times when I wonder if we're going to do a lot of copying, like equals or copy constructors, is it faster to just memcopy, or is it faster to do membership of assignment? Is memcopy faster than member by member assignment and copy constructor? I don't know. Oh, they want to do it in a loop. See, I'm just wondering about like a constructor. I wonder if the overheads of memcopy are not enough to make it worth my while. Okay. Actually, let's go find the operator equals. Let's just add ourselves a note. Two. Memcopy faster. Just in case, I don't know. Also, we might not have very many copy constructor calls anyway, or assignment operators. It might not be worth even considering. Okay, this one. Oops. If encoding is that, and you write that, that, we go back to exactly the same thing we were already doing in theory. So in private, we need clear. Okay, there's the copy, there's the clear. So then one is clear text buffer. So this one where we get buffer and these things. 2, 3, 4, 5. There we go. Put in stuff about fights if we care. Oh, interesting. This all goes here. What's going to happen here? Basically, char offset, char count for everything else. Since we won't have iterated over the text buffer, we don't know the character information. Character offset. Starts at somewhere, goes some length. Okay. So when we give it so if we have a character reference to one thing and a character reference to another thing, that does not look like what I wanted. I want this one. Lots of assertions. There we go. So we assert that we have to be valid, we assert that it has to be valid, or at the end. Oh, I don't know if I have that function. It's all right, we can put it back in. And we have to assert that they're pointing to the same buffer. String reference has to point to a consecutive bytes within the same buffer. So those three asserts all make sense. If we include the last character, the first character and the last character could be the same. Otherwise, we do have to be beyond it. It has to be bigger. And this is simple. So here I think we have probably declared friendship. So we have to make some changes there. All right, so an empty string reference, fine. A reference to two characters who meet these criteria. So that is all perfectly acceptable. This is perfectly acceptable. So go 1, 2, 3, 4, 1, 2, 3, 4. New line quote. These lines seem acceptable to me. except last char invalid reason equals ChrRef invalid reason end of if it's valid or if it's at the end of the buffer. Buffers have to be the same. Include the last character. Okay, now this matters in the case of UTF8 in other codings it does not. So do this. Encoding is UTF8. This is what we write. Oh, and it's not. Just write offset. We don't want to be friends. Think something like that. In the case of otherwise, then the byte offset, it has to be char offset. Okay. So that gets us through our insertions. Regardless, people will write this out. But we only write this out. We are in UTF-8. So I think we can do that. It'd be okay. So first, we assert the things. We can do that. Here we assert the things. We'll put an extra thing in there. Oops. We'll get the extra new line there, that's fine. And then these things happen. Then copy the buffer. End the function. Start the next. The fact that we're trying to support 3 different encodings is a little bit messy, but it's going to be totally worth it. If you want high speed, you go Latin1. If you want pretty fast speed ASCII, if you have to support non-ASCII character, if you don't really have to support UTF-8, we will do it. But it does make reading the code a little bit harder in a few places. Except for okay, VV test parser Of course not. Okay, ChrRef. This we do have the buffer as a thing we can return. Yes. Okay. Yeah, we have too much friendship going on here. Char offset. Bytes. Yeah, okay. So there. That's the membership that we worry about. Okay. Here. Copy constructor, destructor. Assignment. If it's UTF8, we do byte stuff. Which brings us to equals. I think we just stir compare. Oh, yeah, I think so. Yes. Code writing code. We did lose track. So let's go look at the operator equals. So this one I can short circuit the testing a little bit by byte count before I do a string compare. That's the reason for this. We can potentially save ourselves time here. This one is just what you see. So let's see here. This one. Easy, done, not equal. This here is let me think. Yeah, this is UTF8 specific. So do something like this, and this, that. If coding is this, we do that. Otherwise, do something else. Which looks like count. We don't have a byte count. There we go. Uh-oh. There's a parentheses somewhere up there. Take a look at that in a minute. Okay. There. Easy to spot when you're looking for it. Okay, now 2, 3, 4. 1, 2, 3, 4. Oh, okay. One, two, three, four. 1, 2, 3, 4. Okay, there we go. Okay, then we do string comparison int byte count, which should be an easy turn byte count. Char count should be the same thing, easy peasy. ToString. This one is actually 2C-string. We should call it 2C-string for consistency. What's the other thing? With the character reference. Int hash const. I know that we did a hash. I don't know if we want to do a hash. Think about that. I mean, it's a bad hash anyway, so. Oh, it's fine. We can implement it. It's easy. All right, let's go to toStir. Basically looks like this, except as usual. The difference is in the byte versus character. When we're in ASCII and Latin, every character is 1 byte, so talking about a character is the same thing. Not in UTF8, so we must distinguish, which brings us to this point. Where we do this. I thought this would not be that bad, but apparently it is. I thought StrRef would hide more. It's been a while since I've looked at it. Okay. 1, 2, 3, 4. 1, 2, 3, 4. End of line, new line, quote, next. And stringify all that junk. That's basically it. Else, we have to do something else because here we don't do bytes, we do just characters. Okay. Hash. I want to write a hash function. We're actually pretty close to having StrRef done. I mean, at least the first pass, we got to test it and all that jazz. 3:30, I've got time. Let's do the hash. All right. Use a Jenkins hash function. But, as usual, what do I want to do? Because again, we go by bytes or characters, depending on whether we're in a UTF-8 world or not. Let's see. Basically, these 3 lines here. 2 lines. That's the only real difference. So we come over here, we do this. We come over here, F3. Boom. And what we want to do is to indent all of these a bit more. It's these 2 lines we gotta do with 2. One, two, three, four. 1, 2, 3, 4. 1, 2, 3, 4. This is it for UTF8. Otherwise, everything else is just by character. Okay, so we now have a Jenkins hash function installed. In theory. Okay. StrComp. It's going to be different whether we're in UTF-8 or not UTF-8. Okay, as long as the UTF-8 as long as the character references are valid, we don't actually have to do any differentiation between Latin or ASCII within any of the string reference. We don't care. We assume that the character reference is already checked in, so there's no differentiation between encodings there. Okay, so we're going to take a look at the StrComp. These should all work the same, except we're working with bytes versus characters in the 2 different encodings. I don't know that I need this one. I don't think I do. I only need these 2. I'm going to delete that for now. This might just be easier. We do it this way. I think. Really, we're just using a string comp. Okay. Boom. 1, 2, 3, 4. 1, 2, 3, 4. So that's already 2 depths. That's basically that. Other one is a string literal. So this is if we are in UTF8 mode. Otherwise, changing all of the words byte to character. That's basically the only. There we are. This one. So that's that. Clear. The last function, which is basically it's buffer comes first, and we only put bytes in if we must. Right. Woof. Okay. Now, bots today. Good bot day. Maybe we've got it. Yikes. Okay. Let's just compile and see what we missed. Okay. Oh. Okay. Oh, darn it. /0. Did it again. That should fix some of our issues. Maybe not all of them. Okay, well. Ref should be char. It's not that one. Okay, get closer. Insert.m buffer. Let's find another the first char dot buffer equals this buffer. Okay. Dot and underscore. So other is fine. It's the first char, last char thing. Okay, we are getting closer and closer for us. That is this one. That should only happen if we're in UTF-8 mode, which we are. And it's really. Oh, byte count. Okay. That's what I meant. Just size, I guess. Size. Okay. Writing it down. Okay. I agree. Be that way. Turn contents of this. Oh wait. That's where that goes. It's right here. At some point, I was sort of wondering if it would be more efficient for me to say, here's the UTF8 version, here's the ASCII version, and just not have these if statements. It has occurred to me. Okay, unbuffer.act. To act. Contents plus byte offset. Contents plus character offset. Contents plus that stuff. Contents plus this stuff. Ooh, we're getting closer. Still looking for act. I kind of want to break this across multiple lines now. So I think it will be more readable that way. Contents plus a thing. Oh. According to the words per minute typing test I made to work with this interpreter, I type 160 words a minute. That's pretty good, especially programming language. Like typing raw text is like prose. It's a lot faster than writing code because you spend so much time doing syntax, keystrokes, and code. Yeah. Interesting. 160 words a minute. Tell the AI to make it lower. That number is too high, AI. Make it right. I think my math is wrong using Unix timestamps for start and end time. That should be good enough. Another thing you could use is time use clock, or if you're doing C, chrono. Chrono might be more. I think chrono exposes some better clock to you. Oh, it finished. It actually worked. But I want to start testing it now, because we do have to test this across 3. I'm using this AI made interpreter language. Yeah. Oh, I see. They didn't expose good timekeeping for you. Okay. Did you tell the AI to write the words per minute test? Maybe that's the problem. Oh, I'm out of water. Let's see. Where we at? Just about in at 4 o'clock. If I grind out another hour, we probably have enough time to test all 3 encodings with a StrRef. And if that works, he told AI to write it in C++, and I converted it to that interpreted language. Pretty identical. Okay. 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 So what do I want to do from here? Okay. We need to test, except UTF8 still a thing. These are all fine. It's in the stir comp. We get this. StrRef. In TxtBuffer, I specifically said not TxtBuffer, ChrRef. ChrRef, we specifically said what text encoding we're supporting. So let's go to class StrRef and put that in there. You might as well be consistent, right? Should we provide links? We can give links. Let's see here. Yeah, syntax. Most modern languages are going to have a algol-like syntax. Your C, C++, Java, C#. Take your pick. Yeah. I have a link from here. I quite like. Could embed links to like wiki, Latin1 encoding. It's like a Wikipedia version. Latin1 supplement. Not to be confused with ISO IEC 88591. For the 1990s era misnomer ISO 8859-1, Latin alphabet, 8-bit single byte coded graphic characters. Consisting of 191 characters from Latin script. This character encoding scheme is used throughout the Americas, blah, blah, blah. Some popular 8-bit character sets and the first 2 blocks of characters in Unicode. 1.2% of all websites use Latin1 encoding. Eesh. Web browsers and the HTML5 standard interpret them as a superset of Windows 12.52. Ugh. Why? Legacy single byte character encoding is used by default as the ANSI code page. Yuck. Maybe Latin1 supplement is good enough. ASCII plus all that junk. Yeah, let's do this. Let's just declare a const char star text in text encoding links. Okay, do Latin1 supplement wiki ASCII. If I could type, that would help. ASCII is a 7-bit standard. Project 1, 2, 3. Okay. So it's ASCII Latin UTF8. Go to UTF8. Okay, now whatever we do, talk about supported text encoding. We'll put in another line. Will be something. XYZ, either text encoding links. Given int m encoding -1. We support all of Latin1. We support ASCII, UTF8. It's kind of the interesting one there. That character. Okay. Make sure that's files. scalar object requires one element and initializer. Oh, oops. Put in the brackets. There we go. It's a semicolon. Wow, we're off to a great run with this change. Huh. Okay, so it all compiles technically. Now we need to test it. So I think it's time for a snack run. I'm gonna grab a snack, and then we'll start testing all three formats. All three supported encodings. Where are we at here? 800 lines of code? See, that's nothing. It's nothing. It might be simpler to, it might be simpler to just, okay. Yeah, I'm gonna get a snack, and then we'll think about where we want to go from here. Snack run. Okay. So, to be frank, this is making my eyes bleed. So we're going to make a small change. VV project. Right. Character reference. Let's go ahead and rename this. And this one. Okay. Right. Character reference UTF8. And one. ASCII. I think we're going to do this. StrRef UTF8. Again, we don't need to care about the others. There. So these are going to simplify things a bit in a few places and make it worse in others. Go down here. We're going to get a lot more duplicate lines here, but honestly, parsing through that other stuff is not great. When we can simplify the whole thing to a one-line call. Everything will just be in line, no conditionals to parse through. Let's see. This thing. Right, ChrRef, ASCII. One, UTF8. Okay. Now we're going to grab all the text. Put it here. Oops. Here. And here. Now I have to keep track of which one am I in. So like this text buffer, it's literally a single one single line call with one string. I think that's going to be better for me to read and understand. Two lines. It goes somewhere else. When we get there. So this is the UTF-8. So anything that's not UTF-8 goes away. Optical elliptical. Did I miss the beginning of this project? Oh, okay. Let's see here. Oh. Yeah, snack time. What language are you making the compiler for? I'm going to make a language for my own toy language, which doesn't exist yet. Probably not going to be anything that's public worthy. Like if you want to build something good, you build 3 or 4 of them. Sort of make some throwaway languages, play around with it, experiment. And after you've built 1 or 2 languages, I think I'll have the skills for something more interesting, maybe. But yeah, just my own for education purposes. Optical elliptical. Did I miss the beginning of this project? Yeah. So if you go to YouTube, so let's see here my about page. I've got a YouTube channel. I've got a Rumble channel. I also have a Discord server if you want to get notifications when I go online. Or there's a Twitter, also in the about of Twitch. So all the videos are there. On YouTube, there's a playlist for compiler from scratch. And yeah, may not be the most interesting Discord yet, but notifications. Will I be your mentor? I will answer questions, but I'm depends what you mean by mentor, I guess. I'm happy to answer questions and describe what I'm doing. Absolutely. If you want something more involved, well, I'm not going to commit to any more than answering some questions. How's that? Perfect. Yes, I am happy to answer questions. I love answering questions. If you want like code reviews or suggestions or advice on how to live your life, that's not really in my wheelhouse. So as long as we're on the same page, I'm happy. Yep, I'm a software engineer. So what we're doing right now is a compiler comes in different stages. The first stage is Tokenizer, or sometimes called the scanner or the lexer. That's where you take a block of text or a stream of text, however you want to think about it, and you chop it up into words. And those words, or syntax, right? So like if you're reading English in a book, each word is separated by a space, and then there are things like commas to mean lists, or there are things like periods to mean end of thought. We use syntax and words. So the tokenizer does that step. It breaks things up into those tiny pieces of information. So we're building that right now. Yeah. Okay, cool. Yeah, happy to answer questions. Always happy to answer any questions. So the tokenizer is the first stage of a compiler. And it's good to separate the code out that way. There's really not any more logical place to separate your first stage. The second stage is the parser, where it builds those tokens up into a meaningful structure. Then we do semantic analysis to make sure that we're following the rules of the programming language and that what you've typed makes sense. Then you emit code, and that gets into a whole hairy ball of confusion and all sorts of things. What we're doing right now is actually probably not the right way for most people to start their project. A tokenizer is not rocket science. It's pretty straightforward. If you put a loop where you walk through each character in a file and you say, is this a number? You go to the number parser, or if it's a letter, you go to the identifier parsing function. It's just a bunch of if statements inside of a loop where you go over each character in a file. None of that's rocket science. It's probably the best way for most people to start. However, there are things called Tokenizer Generators. I had a couple of people pop in. We're just giving an overview of the project. And we're restructuring a couple of things. It's going to be more duplication of text, but it'll be easier to read. Welcome back. So the thing that we're doing now is what's called a Tokenizer Generator. Back in the day, we were refactoring. We refactor all the time. So a Tokenizer Generator, you specify some rules in a special declarative language, which we will define later. Well, we've partially defined it now. And it will generate the tokenizer for you. So there's like Lex or Flex are two open source. Well, Flex is the open source version of Lex, which will do your tokenizer generator. It will emit code that will do your tokenization for you. We're making something like that, which is maybe not the right way to do it for most people. Honestly, a tokenizer is not rocket science, but we're doing it because I have fun with this kind of thing. We're going to be doing, we have DFA tables that we're generating, discrete finite automata, or deterministic finite automata, I should say. We're using a Thompson's construction. This is fun stuff I find fun. So we're doing it because I like it, not because it's the right thing to do. Personal project. So back to octoelliptical. I have interviewed people for entry-level positions. Yeah, we actually went over that a couple days ago. So if you have any questions, let me know. Do I have an online repository, Mr. Ed? I do, but I only put teeny tiny toy projects on there. I don't feed the AI training algorithms of the world. Yeah, so basically everything in there is small projects, not interesting. Like I have a study I did on random number generators, a bunch of different random number generators, plus the different ways you can use them. So no public repo for the current project or my other main project right now. I'm keeping that code to myself. Pat, oh thanks Pat, my biggest fan. Yeah, so here the philosophy is we add abstractions when we need them. We don't build an abstraction until we find we need it. A lot of people over-engineer their projects, end up using a lot more abstraction, which ends up obfuscating things. So thanks for the plug, Pat. I always appreciate it. Yeah, give a follow if you want to. I go online daily, Monday through Friday, usually around the same time, stream for 5 or 6 hours. Monday through Thursday is game development with no game engine. Again, too much bloat, too much stuff I don't want, so we're just building it from scratch. 4 dependencies allowed there, and then Friday is compiler's day, no dependencies, all from scratch. My C++ style tends to be more C style with a little C++ on top. Pat, I took all my repos off GitHub a couple years back because the AI is scared. I'm not scared of it, I don't want to contribute to it. They're scraping all of that without asking permission, so screw them. Also, I had people who would fork my stuff and then I'd no longer see their fork. Yeah, that's not cool. Then they'd re-upload your stuff. Like, well, yep, there's a lot of bad actors out there. Optical, elliptical, why did they do that? Because people are jerks, or lazy, or both. So, Mr. Ed, optical, elliptical, hopefully that description of what we're doing here brings you sort of up to speed. If you have any questions, let me know. Otherwise, I just kind of stream of consciousness while I code. And then if I get a question, I answer it. I don't always answer right away, but feel free to pipe in anytime you want. So what I did was, let's see, let's go down. So I've written this code to output some code, right? So our tokenizer generator outputs text files which are compiled into your project. And I kind of interweaved the 7 different encodings we support, and I don't like the way it looks. I don't like the way it breaks up the text. So although it saves me words, like I don't have many lines of this stuff, this in and out, I don't like it. So we're breaking that up, we're refactoring into its own special thing. So like this text buffer, this is what's going to hold the text that we're going to parse, and it can come from a file or anywhere. This all is a single string, a single call to write, very easy to read and understand. It's basically like reading code, but within quotes. So we're refactoring so that writing our character reference code ends up being the same thing. Choose your encoding, then write it all out as a single call, one string, no weird indents and stuff like that. So We're in the UTF8 encoding right now, and we're just stripping out everything that we need to, and making it a single line again. So a bit of a refactor. Not the funnest project ever. Refactoring is usually not the funnest, but you can't be afraid to refactor. So much code today is not refactored because people think that makes them a bad programmer or something. I don't know. So here's UTF-8 stuff. We will keep that. We're just going to make it all one big string. No, yeah, that's correct. Okay. Handouts. Sometimes refactoring, it's like, did I already delete that or did I not delete that? So that's for UTF-8. This is not UTF-8 code support. And then we write that out. Thusly, this is UTF-8 support, and within a bunch of other stuff. Then UTF-8 specific code. This is not UTF-8 code. Maybe we're just going to call this value. Okay, then UTF-8 code. Go like that. Blow away Latin and ASCII because we do not care here. Yeah, so I'm going to give you a little philosophy here. I don't think that there are hardly any software engineers in the world at all, period. Because I have never in 15 years of, well, it's more than 15 years. I've been coding, oh gosh, anyway, it doesn't matter. More than 15 years, I have never been given a design spec sufficiently detailed enough and accurate enough to engineer a solution. It is always vague and wrong, and it just doesn't include enough information to actually engineer anything. So what I think of is software development is more like craftsmanship. So if you look at how like a painter works, like they'll sketch some things in and they'll start slapping paint on there. And what you'll find is that they end up going back and changing lines and moving colors around and all sorts of things. Same thing with like a carpenter, right? I think coding, as practiced by most developers, is probably more of a craft. Somebody making a very expensive set of cabinets will often, cut the boards to a little bit oversized, put them all together, and then they'll sand it flat. Like they didn't engineer it to go together perfectly. They engineered it. They crafted it. And I think that's what a lot of modern software is. Now there are places where you actually engineer software, and that would be in places like flight critical systems. They'll tell you this airplane's going up in the air. It costs $1 million to build one, and the pilot's training is worth who knows how many millions of dollars, plus all of the support crew and the maintenance crews. You do not screw up. So he will tell you we are using this processing chip. Period. You have this many frames. You have this many hertz. You have this much memory. Here's your data bus protocols that you're allowed to use, and you're not allowed to use more than this much bandwidth. And your response time must be from cold start this many milliseconds. Like they will tell you every specification about the system, and it has to work. Period. Yeah, exactly. NASA is disgusting about how careful they are. That's hundreds of millions of dollars plus expensive astronaut lives. Not that their life is worth more in the moral sense, but when you spend that much money training somebody, you really want to get them back. Those software engineers are actual engineers. I don't think there's a single other field that I can think of where you actually have a specification sufficient to engineer any modern software. So that's my mini rant over. So yeah, don't be afraid to refactor. Like, that's part of it. As you're writing your software, you're discovering your requirements. And I've said it before, I've said it again. If you want to build something good, you build it 3 or 4 times, right? You build it the first time, and in that time you learn what it needed to be. Then you build it a second time, and the second time through, you're starting to refine things. You're like, okay, I know how it works. I know what happens here. I know I didn't like that the first time. I didn't like that the second time. By the time you've built it 3 times from scratch, you have a pretty darn good idea how it works, what it should do, and what the requirements actually are. So that's what we're doing. I've actually built a couple of different toy compilers over the years. So this is me doing my 3rd or 4th time through, trying to do it more right than before. So yeah, there's my philosophy on software design, software engineering, whatever you want to call it. If we're in UTF8, we do this. And that gets written regardless. So put some new lines in here. Funny about thinking the NASA engineers, how much smarter they might be than me. I always imagine them being able to write assembly in the most popular architectures blindly. Yeah, I mean, so I did some contract work at NASA. Nothing on the flight critical systems, so don't think I was in one of the smart ones. But at that level, they actually get enough information to engineer something. So I don't know that it's necessarily a skills gap versus somebody actually defined the system sufficiently accurately that they could do it. So I think that they are very, very familiar with the architectures that are supported, because NASA does not move fast. If they say this is a chip architecture we support, they will learn it inside and out, because it'll be years before they move off that. Modern PCs, how do you know what chipset you're going to support? You can't. There's no way. Octoelliptical, what do you look for in entry-level software engineers while interviewing? Does language matter? Like, am I good at C++, made a project in Python, which I include on resume, and how complex a project should be given for someone applying for an entry-level position? And if one good at problem solving and data structures clears the technical rounds, they've got simple projects and resumes, all right. Okay. What I'm looking for in a new grad hire, and I'm not hiring, by the way. I'm basically burning through my life savings right now to build my own thing. What I look for in a new hire who's fresh out of college is I want to see, more than anything, passion and interest and energy. Okay? So I will ask questions like, I've done this one a bunch. Like, hey, so here's the most important question of the interview. It's like one of my last ones. I'll say, Emacs or Vim? And if they say something besides, I don't know, I guess I use VS Code, right? That tells me that they didn't care enough about their craft to learn the tools. If they came back and said, oh, well, I looked at Vim and Emacs, but I'm using, what's a good one? Atom or something, right? And they could tell me why, and they were interested in it, then I knew that they were interested enough to learn. Having small projects on your resume is great. Being able to describe it. Let me pull up a reference here. We just did this the other day. So let me find this. They'll ask you, hey, was there a time in a group project where such and such happened? Those kinds of questions you want to answer with the STAR method. So there's a link for you. Basically, it is a way for you to structure your answer. So you'll say, here's the situation. We were working on a project to do this. Then you talk about your task. My job was the database interface, or I don't know, whatever it was. And then you talk about the oh gosh, I've already forgotten. What's the action? Here's the action I took to achieve the end I needed, and here are the results, right? So situation, task, action, and results. That's kind of a way that you structure those answers. Was there a time on your team when you didn't get along with somebody? Well, here's the situation. Here's what we had to do. Here's why we didn't get along, and here's what I did to fix it or to mitigate it. And here's the result. Right? We finished the project. It was on time, and this feature didn't get done. I don't know, whatever it was. So being able to answer questions that way is going to be very important for you. Basic data structures, basic algorithms, all of that's going to be useful and good. Modern software companies really like giving leak code questions. I don't. So depending on if you're going for like the big FANG companies, I would say do a bunch of leak code problems online. There are tons of free leak code practice places. But what I wanted to know was, did you know the basics, right? So I would give a very, very simple function. I'd be like, hey, write a function that averages a list of integers. And if they struggled with that, I knew they didn't care. They didn't know. If they didn't know how to do the simplest thing, maybe I would give them a function that would print out the number of consonants or vowels in text. And if they were struggling with that, I didn't want them. If they could do it quick, like actually it correlates interestingly. The faster they solved the simple problems, the better able they were to deal with the more complicated problems. It just meant they had more time at the keyboard writing real code. Leak code problems are sort of in this bucket of, have you seen a similar problem before? Have you done so many leak code problems that you recognize this? That's not as helpful to me. But if you're playing the game and trying to get into the big companies, Amazon or whatever, leak code problems are probably your way in. So those are some things I would say. If you can intelligently describe a project in a structured manner, that's good. Answer their behavioral questions with a STAR interview method. You're not going to have any experience to really talk about, so play up the big class projects. Those are your in, unless you've done like outside of class projects that you're also good for. And then show competency at the easiest levels, and then show interest and passion about programming itself. Your tools, your languages. What's your preference? Why? Me, I hate Java. I hate C#. I don't like Rust. I want C is almost perfect, and I can tell you why. What C++ standard libraries do I like in C++ 11 or 23? I can answer those questions because I've looked at the tools and I've looked at what's available, and I know what I like to use and what I don't like to use. So have an opinion and don't be afraid to say it, even if you disagree with them, right? Like I've been saying for years in interviews, I don't add dependencies unless I absolutely have to. And then, of course, they hire me, and then they shove all these dependencies down my throat. So, you can't win them all, but have an opinion and have a way to argue about it, have points, have reasons for it. I don't know if I'm missing anything, Pat. I think that pretty well covers what we've talked about before. This has come up 2 or 3 times now. Maybe it's time for me to sit down and write up a PowerPoint slide deck that we can whip out when we need it. Yeah, Octolyptical, always happy to help. Like I said, I don't mind answering questions. Love it. Yeah, maybe it's time for me to set up a project complexity. By the time you're out of college, you've done a few hundred lines of projects, right? A couple of projects that are a few hundred lines of code, maybe. I don't know of... There's not really large-scale projects in college because you're limited to a semester and it's not your only class. So if you have a personal project you've done on your own, have that in a GitHub repo. You can show and talk about it. That's perfect. Few hundred lines of code. If you have something bigger, more interesting, pull it out, yeah. But honestly, they're not looking for anything too big. It also kind of depends on what field you're going into. If you're going to be a web dev, you know, the project complexity for a fresh grad. Do you have an example web page? I guess is that that's kind of what you need there. But I've done a lot of different kinds, so like a web page is not interesting to me at this point. It's just another tool. Kind of like databases. I don't ever want to be a database engineer. I don't want to be so focused on that one thing. It's a tool. I can use it, but I'm not going to dedicate my whole life to doing that one thing. So if you want to focus in on a particular field, like robotics, for example, have examples about robotics. If you want to be in graphics, you should have some OpenGL or Vulkan-based projects on your GitHub repo ready to show. Does it have to be associated with a specific language? As a new grad, I was less worried about you having a specific language. It was nice. Yeah, different projects, different tech stacks, absolutely. Always helpful. Once you've learned 2 or 3 languages, and if you can show that, I'm less worried about people picking up another language. If people are like, oh, well, our school only did Java, then I have to assume that you've been, your brain, your development has been crippled. So if you know 2 or 3 languages, if you have a couple different tech examples, you're probably good. UTF8, that's where we're at. UTF8, UTF8. I'm just making sure we've got this more or less where we want. Like, I didn't learn UTF-8 encoding, how it actually works, until just a few years ago. It's kind of embarrassing. People are so high level and talk about abstraction as if it's the best thing in the whole world, but then you don't know how things work. Or UTF-8. Not ASCII, not Latin1, UTF-8. So yeah, of late I've been trying to push my knowledge of programming deeper down into the stack. One of these days, when we get further along in the compiler project, I really want to emit binary to the Windows executable file itself instead of going through a linker and all of that. I've downloaded the manual for like Intel x86-64 architecture. I think it's going to be awesome, but that's still a long ways away. We're nowhere close to that. How badly did we break this? Oh, I need a parentheses. Stop. Friend, or not friend. It's supposed to be enough. Yeah. Okay, that looks okay. This function needs the same treatment. Oh, almost the same treatment. Here we are. Okay. It's going to explode my line count, but I think that's so much easier to read. I think it's worth it. Okay. Yeah, no problem. Like I said, always happy to give an opinion, even if nobody else agrees with me. This is the Latin1. We need to make sure we don't delete Latin1 stuff. Not doing UTF8 here. Yeah, come on. Previous, there we go. Here's over the wrong line. UTF8 goes away. Yeah, I'm just gonna, like I said, keep coding stream of consciousness. Pipe up with any questions if you have one. Project specific or not. I'm not that picky yet. Maybe someday I will have so many followers and so many watchers that I'll have to shut people down just to get things done, but we're not there yet. I'm enjoying it. Just having fun. UTF8, Latin, well, ASCII. All right. Just slowly grinding away at this. Like I said, a lot of the times you just, oops, that was UTF8, wasn't it? It was. That can all go away. UTF8 update. It's so much of a heavier lift than Latin1. ASCII. There we go. Yeah, something we're trying to do is support 3 different text encodings from ASCII, which is valid values are between 0 and 127. And why that is interesting. Story time, but we've done that one before. So the ASCII is 7-bit encoding. And we're trying to support Latin1, which is basically not used much anymore. Like if you look at modern websites, we just looked this up. It's 1.2% of the websites in the world use Latin1 encoding. So not the most used, but what it is freaking fast because we don't have to check the values of any of the characters. So if speed is your number one concern, we will support Latin1 encodings. And then UTF8 for obviously all of the other things you would need to do. CQ. In the region, we're going to steal that from this one. Oh, it's short. There we go. All right. Last one. We're almost there. It's times like this when I regret some choices, but I was just trying to be too clever, trying to save lines of text, and instead I just made it harder to read. So we read back. Okay. No UTF8 allowed here. No UTF8 allowed here. Oh, this is the UTF8 version. This is the not UTF8 version. No UTF8 allowed. It's fun. UTF8 gone. Let's see here. UTF8 goes away. We'll update function. That's a big one. Latin1 ASCII. Is a little bit heavier weight than Latin1 in terms of computation. Not much, but like I said, if you really care about speed, we'll provide you Latin1. Travest, yes, get some sleep. Sleep happy dreams. And I'll see you next week. Thank you for dropping in. Have a wonderful weekend. This one is ASCII. Switch state goes away. Oh, what about it for? Let's do this. There we go. Okay, so that should fix all of the character output. Probably messed up something, but it's okay. I think that is easier to read. Or duplicate lines of text, but I don't care. Which brings me to the last piece of this refactor. StrRef for UTF8 and StrRef for not UTF8. Wow, wrong brackets. There we go. This one isn't as big of a class, really, so shouldn't be that hard to unravel. Here we go. It is ASCII or Latin. We write StrRef non-UTF8 as we write StrRef UTF8. That's it. All right. Here we go. This one is the UTF8 version. Yes. This is UTF8. This one. There we go. Okay. Go down. This is UTF8. One. There we go. Turn this new line. Check for equivalency. Okay, refactor. Okay. This is UTF8. This is that. Yeah, keep that one. To C string. Easy. Write up a little hash function using a Jenkins hash. Why? Because it's easy. We're almost done. Oh. Okay. All right. Last one. Whew. Non-FT UTF8. Okay. Yes, refactoring. Oh, get in the mode. All right. Getting close. Getting close. Then it'll be testing time. Eight. Go away. Overload our own speed stuff there. Clear. This is not UTF8. Okay, I just grab this there. We see how badly we did on our refactor. Right, text buffer. Ooh, I'm so close. I almost want to. Okay, we're doing it. We're doing it. We're just making them all the same, like C text, ChrRef, TxtBuf. Okay. At least we're consistent, right? Okay. Where are we at? 5 o'clock? Yeah, we got time. We got time. Yep, I didn't mean that. I really did. We're calling this value now. Hey, it compiled. Okay. So we're starting off with UTF8. So we have a Greek letter in there to test against. We're loading that into our buffer. Right on the buffer size. Here's our character reference test. We could do a couple different things here. Octoelliptical. Why are you building this? Well, because I am. This is the kind of puzzle that intrigues me. Writing code that writes code to process text, which is then used to build your program, is interesting. It deals with how do I take text and turn it into an NFA, a non-deterministic finite automata? How do I turn that into a deterministic finite automata? And how can I have some ideas around things that I've never seen any other tokenizer generator builder for, which we will get to eventually. I also want to measure speed in a way that I've never had time in a professional setting to do. So, for example, eventually we're going to build an iterator for the text buffer and an iterator for the string reference. But my suspicion is that the basic for loop is going to be more efficient than the for each loop. I've kind of measured it before, but I want to measure it in the full context of an existing real system. So we are actually doing lots of things. For example, in VB test parser, you'll see that there are pound defines for different ways of opening files, right? So we can use the system call open, we can use the library call fopen, or we can use a modern f string. And just by toggling this flag, I get different behaviors. So I'll be able to emit this code, set a bunch of flags, and measure the performance, and actually know how much it made a difference, right? So in the case of a compiler, you have your tokenizer, you have your parser, then you have your code emitter and this, that, and the other thing. In the context of a full parser, how much does this matter? I don't know. I know which one is the fastest, and maybe we even do like a memory map here as well. But the point is, I don't know how much this matters. Iterators versus a for loop instead of a for each loop. Which one's more efficient? Well, I know, but does it matter? Like, is it enough? And nobody measures this stuff. Nobody measures anything. So I've got at least 3 different structural ideas on how to structure the tokenizer state machine. And I just want to measure it all. I want to see how it all works. This is for me to experiment, to play. Like I said, Friday is compiler's day. The rest of the week I'm building a game with no game engine. Again, because I want to know how things work at the bottom level. Unless you build it yourself, you don't really know. All you know is best practices that people tell you, which are often wrong or lack context. The more you build stuff yourself from scratch, the better you understand it. People are always saying, "Oh, well, code reuse is the optimal best thing ever, and don't reinvent the wheel." It's like, yeah, but how are you going to understand what you're using? How come you don't lose patience with building this code or with other people's coding practices? I don't lose patience with this project because this is the kind of project that tickles my fancy. It hits all the right centers of the brain to make it interesting for me. Web development I find unbearably boring. So this is just the kind of thing I jam to. Why do I not lose patience? Because I've built so many large projects over my career now that these little, why is this way? Why is this that way? Why do I have to go refactor this now? And that's going to take me 45 minutes. I don't care anymore. It's all just the way things have to be. One of the things that makes you a great programmer is being so bullheaded stubborn that you just won't let it go. You just won't stop trying to fix the stupid thing. You actually haven't been here for other streams. I've actually lost my patience with my compiler. We have a bug, and there's a thing that I declared a friend, and I should have visibility to it, and my compiler will grant visibility to this other private member, but not to that one. So I had to make it public, and there's a whole big paragraph comment in my code. This is the stupidest thing ever. Why is GCC like this? It's just part of the game, right? You're using someone else's tools. You deal with their problems. The way they designed it and built it affects you. So Patience is just part of the game. You get frustrated, you yell at stuff, you throw your Coke can across the room and explode it. Not me, a coworker. And then you move on. You sit down and you figure out a way around it. My debugger, half the time I fire things up in GDB and it finds what I want pretty quickly, and other times it's absolute garbage and it takes me 2 hours to figure out why the thing is happening the way it is, and I have to use print statements. Good old-fashioned print statement debugging. The debugger was useless. Yeah. You take the win on the times when the debugger was actually useful. I don't know. It's just practice. 15 years of fighting technological stupidity. You also have to realize programming is part puzzle solving and part explaining very, very simple tasks to somebody so stupid that they can't understand simple tasks. The computer does nothing but follow your instructions exactly. The computer is not smart. So when you realize that you're explaining very, very simple things to an idiot, a lot of things about computers start making more sense. It's an imbecile. It knows nothing. It has no context. It has no understanding, which is one of the reasons that modern LLMs are, unfortunately, providing a veneer of humanity without having any of the things that makes it human. So a lot of people are on the hype train right now. I think in a year or two it's going to hurt a lot of investment people, but that's a separate discussion. Yeah, computers are dumb. Just explain it to them very simply, and they'll figure it out. They'll do what they're told. Not they'll figure anything. They don't figure things out. Did my compilation finish? Did. And we are in. This is my Villian-Vey project definition. The name of the project is test. We're in UTF8 encoding. There's where I find my tokenizer in that file. So I can test.cpp. Do I want to look? I want to look. I do. VV test parser. The other one. There we are. Reload it, and let's just see if things line up. Okay, we've already lost one. Which immediately line after that. So VB project writing till, yep, that should be like that. I seem to have changed styles halfway through all of this. Not sure which way I prefer. Anyway, so that was white space issue. Those three are fine. Okay. Don't see any issues there. These are the different file opening methods, right? So instead of, we're using a modern C++ F stream here. Copy text. Blah. Reference text. Clear. Oh, okay. Let's go back to class ChrRef. This thing, for some reason, has two. Put all places. Okay, back in here. Oh, I see. Go find that again. This one I want double lines. Double lines. Double. Okay. That all looks correct. Also, just making sure text aligns and the amount of white space is reasonable. Could shrink all of this quite a lot. Yeah, it doesn't matter. clear update, etc., etc. Okay. Oh, okay. A couple of issues here. We lost a new line here for invalid char. Yes, we are using go-tos and labels. Sometimes it is the correct answer. Not always. Got a new line here. And there. Really, there's only one of those? Oh, that's right, because it's UTF8 specific. So, alright, let's go take a look. DB test parser load. Okay, so we did fix that one. This all seemed okay. Advanced clear update. That looks better. That laid out correctly. Right, string reference. How badly did we screw this one up? Dun, dun, dun. Yeah, yep, yep. Oh. Mm-hmm. We messed up our Jenkins hash function somewhere. An if statement in there. Or for. Oh, that's the problem. Probably actually lays out correctly like that. New line, new line. Okay. Stir comp looks okay. Aha. Somewhere we got an extra new line. Return result. Right there. Is non-UTF not using stir comp? Okay. And stir comp. That all seems reasonable. Clear function. It's okay. Yeah, who might feel it? We're gonna change it. Oops. There we go. Oh, okay. Refactor almost complete. So that is the end of the string reference class. That is the end of my namespace. So in theory, this thing still works. Now that's just the, yeah, let's go to test CPP. That is iterating through by character. Test parser, string reference, s, given the buffer. Char, temp equals s dot value. We will delete temp availability. Then we will text. This is the simplest thing we could do. Okay. StrRef. Given a text buffer with defaults. Oh, why would I do that? Why would I do that? Okay. All right. StrRef, print, const, whatever. It's the next one, this one. We don't want to do this. Pointer to a buffer. There we go. Okay, so our text is that that's not really the interesting piece here. So we're going to do buffer from, what do we got? Go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 10. 10, 10 and 5. Offset 10 bytes, 5 bytes long. So that should just be world. Oh, let's. S1, S2. Full string. S2 value. Short string. So this one should give just the word world. that. It did. Nice. I counted characters correctly. Okay. Then, last piece we want to test is actually two pieces, I guess. Alright, we're gonna do this. Find log character. It's gonna look a lot like this. C1, character 1. We don't care about the index. If C dot count is greater than 1, break. Then we get a second character from the same point as C1, so copy constructor. And we're going to say if C is equal to a space, break. Then we form string 3 from those two characters. String 3, C1 to C2, not inclusive. From character to character string, we might as well make it as inclusive. S3, where's S3? There it is. True. We'll make S4 be inclusive. This is a good enough test. So this is not inclusive of the second character. This is inclusive of the last character. Okay. All right, let's see how that goes. C was not cleared. Here, this is C1, this is C2. C dot byte count, C1, C2. What is our char reference? PV test parser dot ChrRef byte size. Okay, all right. Let's see how those substreams look. Okay, so that got it started with the long character and then went until it found a space but did not include the space. This one did include the space, so perfect. Absolutely perfect. Let's do a little bit more details here, just because we can log note modulus d bytes, modulus d. Oh, getting close to being done here. characters. So that is s2 dot byte size, s2 dot char byte size byte offset char offset. Okay, so sizes and offsets is what we call them there. In a string, byte count, character count. Well, we're not very consistent, are we? Yuck. That is something I'm going to have to fix. S1, S1, S3, S3. S4, S4. Yep, we're going to have to make that consistent sometime. We might have time to do it today. I've got 15 minutes or so left. Okay, so this one is 16 bytes, and we did not count the number of characters in it. This one, same thing. We did not count the number of characters in it because unless you walk every character inside of it, you don't have a character count. So that's fine. We got the right number of bytes. 1, 2, 3, 4, 5. This is 16 bytes, which TxtBuf agrees with. From character to character, we have 3 bytes, 2 characters. So this is a 2-byte character, then the comma is 1. 4 bytes, 3 characters. 2 bytes, 1 byte, 1 byte. Yeah, I agree. Perfect. So that's working. VB project writing byte size byte count. I'm afraid I should be more consistent sometimes. Char size? Is that a thing? Nope. Let's search for it. Char size. Yeah, nobody uses that. It's char count. Yeah, exactly. So file. Oh, put a test and change that real quick. Byte size. Byte count. Networks ship it. Yes, yes. No, this is all the not regular expression specific stuff. The fun part comes maybe in a week or two. I only work on this on Friday, so it's kind of hard to keep momentum going. Let's run that again. Everything works fine. Okay, so what we are going to do though, we're going to update our journal. StrRef can now be generated. Oh, we need to do more tests. Okay. A couple more tests. Test.db project. Hello. Test.db project. We're going to say that we only allow ASCII. Then test.cp. We do have to change this to something else. This is ASCII, and that'll be happy. It will not find a large long character. So it's going to find the first space. Because we don't have a byte count here. It's going to find the first space. And then advanced, C1.advanced. We'll advance one more time after we find a space. Then we'll find the next space. That's what we'll do here. There we go. Yeah, sure, we can save the journal. We're working in it. Oh, gosh. We done screwed up. Clear was not declared in this scope. Yes, reread it. Oops. Yeah, I was afraid of that. We threw some code away here. So ASCII. That's the UTF8. We tested it. It worked great. ASCII somehow is struggling. Oops. Oh, right. Non-UTF8. That's what I was looking for. Okay, well, we've got that in line. Somehow we don't have a clear function, huh? Well, we'll just steal it. It comes in after the stir comps. Stir comp. Oh, we didn't even get the stir comps. Whoa. We have made some error. I think we just steal all of this. Where did we stop here? We got as far as private and then nothing else. So we need all of this. Here. Except this is non-UTF8, so we don't count bytes. We only count characters because a character is a byte. Change byte to char in some places. Possibly not all the places, but I guess all the places. Okay. All right, let's try this again. Okay, closer. And we did it again. StrRef, which accepts a buffer, should take a pointer to a buffer. Thusly, not value. So they're the 2C string value. Huh, our refactor was not very clean on that, was it? Oh, in this case, we don't have the difference between bytes and characters. They are the same thing. So we are not UTF-8 anymore. Oh. Just make sure we've got this good enough. Okay, files. It runs. The short string. Oddly, went up past the edge of the thing, so that's fine, I guess. This one, we went up to. Okay. 8 minutes or so before I need to start wrapping up here. So let's go. The short string needs to be a lot shorter. It needs to be Maybe go 0, 1, 2, 3, 4. 2, 3. Let's go 4 and 4. There's a short string. We'll go 4 and 4. And I look for a space, which is, oh. So we found a space, we went forward. Then we need to look for something else that is not a space. That would be a problem. Let's see if that makes more sense. Okay, so from the O, comma, space W, that is as expected because we said 4 and 4. So 0, 1, 2, 3, 4 starts here, and then we go 4 characters forward, and that's that. So good match. We found the space, we went past it, then we progressed until we found an exclamation mark, and this string did not include it, this one did. 5 and 6 characters. Yep, I think that's it. So that's ASCII test.vb project. Let's do this with Latin1. And we can actually do this. We can handle this string, but it will not print that character correctly. This 244. So what we're going to do for we can go to 5 and go 1, 2, 3, 4, 5. So we'll go 5 and 5 for this one. 5 and 5. Here, we're not going to search for this. We're going to search for C1 dot value greater than 127. Search for C2 dot, oh, C2 value equals slash, what did I say, 244? Yeah. That'll be my 2 characters we look for. Let me create our string references and go. First character is not valid. That's interesting. Got our buffer. This one should be okay. I'm gonna search for that one. Oh. If they're not valid, then what are they? 64. Yeah. Oh. Character reference doing something goofy. Definitely didn't come out right, did it? Invalid. Go to here. Failed. String reference given to primitives. So it's this one right here. If C1.is valid, it's not valid. Log note C1 is not valid for a reason. C1 dot invalid reason string. C2, C2, C2. They're both at the end of the buffer? One. Huh. Need any of that. How does it get to the end of the buffer though? So what is the value? That raises the question. The first one is invalid, the second will be invalid. It will not do anything useful. Note C1 dot value. If it's just always 0 or something, I'm not setting it properly. So that's a possibility. Is there a... Oh, I'm looking for greater than 127. I should look for less than 0. That makes more sense. Okay, that'll probably work better. Oh. 6 minus 164. We'll try it. Okay, C2 is not valid in the buffer, so it's actually 255 minus 164. No, it's backwards. There we go. 256. 255. It's one of those. It's not valid, so 256. There we go. Got our 18 bytes. Full string includes the omega and the 244. We searched for 5 and 5, so 1, 2, 3, 4, 5. Then we got 5 bytes. 1, 2, 3, 4, and 5. So that's 5 and 5. That looks correct. This one, we searched for the first negative number, and then we looked for the next negative. Well, we looked for 164. And this was non-inclusive. This one is inclusive. So there, we finally tested all 3 encodings. Based on the project encoding configured. And we did actually test them all. Tested in test.cpp. Make file is still hacked up to make the testing work. And don't forget that. Okay. Added StrRef tested with all text encodings. Boom, done. Phew, just in time. Okay, so next week we will pick up with setting we're going to generate another file called the context. Not a file, but another class called the context. As you move from stage to stage of your compiler, there are things you want to carry with you. One of those things is going to be something like error messages and warning messages. We're going to have a list of them, right? So we're going to put it into the tokenizer, our text, and when the tokenizer is done, it will have a list of errors. If there are no more errors, if there are no errors, let's see here. If there are warnings, it'll log those. If there are errors, it'll log those and fail to move on to the next stage of the compiler. There's no point in going to the parser if your tokenizer has failed. So things like that. It will also maintain other things. But we need to think about the design of context carefully, because in the future, we will have a thread pool for parsing multiple file projects. And so each context will be given to a thread to be parsed into, and it will contain the results of interest to the parties. So this context needs to have a little bit of thought put into it. Or at least we need to not shoot ourselves in the foot about multi-threaded operation. Like there shouldn't be any static state, things like that. So we got to come up with a context. Once we have the context, we'll know how to build the DFA state table, which we can already derive the table. We need to generate that code based on what the context needs to fill up. And that's the plan next week. We're going to start with this and see how far into this we can get. So thanks for coming. Thanks for all the comments. So forth. Hopefully you join me for game development Monday through Thursday, compilers on Friday. Give me a follow. Go check out old videos on YouTube if you're, don't have enough context what we're doing. Everything is there. Tons of hours of it. And yeah, have a wonderful weekend. See you all later. Yep. Bye-bye.